Okay, so this is lesson 35, the day 2. We're going to work through another example here. So here we're going to act as book publishers, and we're trying to figure out how to use the least amount of paper in order to make this book, okay? But we have certain parameters that we want to follow, okay? So, here's the page. I outlined it for you since it was a little hard to read. It says a rectangular page is to contain 24 square inches of print. Those are the words, okay? So, that means on this page here, this little piece here is going to be 24 square inches. Okay? Now, another parameter of this situation is that we want set margins, okay? Maybe we want to be able to write notes in the margins, maybe it's some kind of a textbook or something, or maybe we just like how it looks. Whatever the reason, we want there to be left and right margins of 1 inch and top and bottom margins of 1.5 inches. Okay? So, we say here that the margin at the top and bottom are 1.5 inches, margin the left and right are 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Now, in the diagram here, they actually gave us X and Y. They made X go from here to here. So, if you think about it, that's how tall the text is on the page. And they told us that Y went from here to here. So that's how wide the text on the page is. All right? Now, if I'm talking about the least amount of paper, obviously we're minimizing something, but what are we minimizing?
The XY space?
Now, the XY space has to be 24 square inches.
The outer, the empty space.
Okay, we're kind
It's a
of...
book with that big indentation. So
Okay, what'd you say?
The area of
What?
the empty space.
Area, okay? Area. We're minimizing area of the page. Now, we know the text has to take up 24 square inches. You can look at this by just looking at a function that represents the white space. And if you minimize that, it will minimize the entire page. But you can look at the page as a whole as well. But this is important to recognize because that's going to tell us what function we're working with. It's the area of the page. Okay? So, how tall is this page? Yeah, x plus 3. It's this whole length here. X plus 3. And how wide is the page?
X plus 2.
Yeah, x or y plus 2.
Same difference.
Okay? Now, is that a function of x?
No.
No. We got to make this a function of x. How are we going to do that?
XY equal 24.
Very good, Jerry. xy equals 24. If xy equals 24, what does y equal? 24 over x. Now, we can write our function a of x.
Oh, that makes sense.
It's x plus 3.
And then 24 over x plus 2.
There you go.
Epic gamer moment.
Okay? Now,
Find the derivative again.
we're going to find the derivative.
Find the maximum, the minimum.
Yeah, we're going to find the minimum. Before I do the derivative, what would you recommend we do?
Simplify.
Yeah, let's simplify. Let's foil this together here, guys.
Why are we doing the derivative again?
What are we trying to do in this problem?
Find the
Find
minimum.
Find the minimum. So when you hear minimum, you think derivative, okay? So 24, we're gonna have a plus 2x plus 72 over x plus 6. That's what we get when we FOIL that out. Okay. Simplify a little more. 2x plus 72x and negative 1 plus 30. So there's our area.
And we can find the derivative.
Now it's super easy to find the derivative.
It's 2 plus, minus 72. X is negative 2.
Good. 2 minus 72x then negative 2. And if we're finding a min, we want to find where this is either 0 or undefined.
0.
Where is this undefined?
0.
Yeah, undefined at 0.
When do you bring the
Wait, what? How did we get 2 minus 72x?
derivative?
Oh.
Okay.
Would you bring the x to the bottom, or would you just leave it at the top?
Well, it's an x and negative 2, so we can bring it to the bottom. In fact, I'll do that here and take it to the other side. 72 over x squared has to equal 2. So that means x squared has to equal 36. So x is plus or minus 6, and I know it can't be negative 6. So that means x has to be
You're right.
6.
That makes sense, though.
Okay?
Is that scaling what?
Now question,
That's what I was thinking too, but...
I do have, guys, I do have a sign diagram, negative 6, 0, and 6, just to confirm that this is a minimum point. Okay? Josh,
Sorry.
Where did you get rid of the negative on the 72?
I added it to the other side.
Oh. Oh.
Okay.
Oh.
So when I do my sign diagram here, if I plug in, say, a negative 1, I'm going to have 2 minus 72, which is negative. If I plug in a positive 1, I'll also have 2 minus 72, which is negative. If I plug in something bigger than 6, like 7, I'm going to have 72 over 49, which is less than 2. So 2 minus that will be positive. And same thing over here on the other end. So notice here that the minimum is going to be
6.
right here when x is 6. And that's the only realistic answer anyways. So what is the answer to my question?
6
by 9.
8 by
Have a
7.
good game.
Wait, 8 by 7?
8 by 7, yeah.
I'm
Because you have to add, since the x value is plus 1 and 1/2 on each side, that means it's
8
6
by...
8 by 7.
I did this math without any of the calculus. Like,
Oh, wait.
8 by
6.
Do we have it now?
Yeah, you guys are missing.
If x is 6, what does y have to be?
4.
4. Okay, so 4 plus 2 is
6.
6. Alright, so it's 6
Oh.
inches across the bottom. And it's 6 plus 3, 9 inches tall. So that's the page we want to design to minimize the white space around the outside while still having the margins that we want.
What function